What is going on, Year 11 Journal Mathematicians? Mr. Herman here, and this is going to be lesson 9, exercise 6G3. This is the third video from the 4-part series for 6G, determining the equation of a line of best fit from its graph. And there's this new terminology here that we haven't seen before, line of best fit. Now this is going to be a pretty long concept to talk about, so I'll probably split this video up into two sections, part 1 and part 2. So for all linear models we have dealt with so far, the slope for the models were either given or calculated from a straight line graph. Linear models can also be created from that data. So we get a line of some sort and we make predictions from it, we make assumptions, and it fit into a nice straight line. But the thing is, in real life relationships between variables, they're not perfect. They're not perfectly linear. As I was discussing before in the previous video, we were talking about how the depreciation of a car's value, it goes down, and it goes down significantly as time goes on. It doesn't go down in a linear, consistent fashion. This isn't real life, okay? This isn't real life between the variable. And when it says here, the relationships between variables, it specifically means two variables. Okay, so we need two variables. When we're talking about the car depreciation, it's the car's price in money versus its time in, say, years. It's always something versus something when we obtain this data information. Now we are straying into a data field. You will definitely see this type of work popping up. But right now we're just focusing on seeing if we can fit an equation into these data points. So the data in the plot to the left here, it doesn't exactly lie on the line. But the values do follow a linear trend. We can see here that, let's say some survey was taken and we asked people, what is this as one of your variable, and they give you an answer, and then what is this as another variable, and they give you an answer. So maybe it's what is your arm span and what is your height, and they give an answer and they map it out to a graph. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people were given this question and these were mapped. Obviously, it's not going to follow a nice trend line like this. It kind of hovers around this line, but we can put in what's called a line of best fit. So being able to model this linear trend is a good start to understanding any underlying relationship between the variables. Well, what relationship can we make with this prediction that we just made up here? We can say that the longer the arm span, the taller you are. It's safe to make that assumption. And we've got this data here to show you this trend. Hey, let's put some concrete mathematics behind it and just put a line of best fit here. And it's an approximation, okay? It's not perfect, but it's the closest thing to it. Obviously, we're not going to draw a line up here or down there. We're going to draw a line that cuts straight through the middle of it. So when a straight line does not exactly fit a set of data, we draw a line of best fit, as I was talking about before. There are many ways of doing this, but the simplest way is to use a ruler and draw a line on the graph that seems to balance out the points around the line. This balance out is very, very important because you have to take every single point that has been given to you into consideration. This is called fitting a line by eye, and it's obviously by eye because we're using our eye to determine this. However, this is also the least accurate method. You will be seeing more accurate methods as we get into the data field, but for now, we're just going to focus on this fitting a line by eye method. So to fit a line by eye, make sure that there are an equal number of points above and below the line, and I'm going to say that there are an approximately an equal amount, or very close to equal amount. It doesn't have to be exactly equal, else you'll just be there forever trying to count if there's some above and some below. And the points above and below are spread evenly along, not bunched at one end. Okay, so these are two important facts you have to consider. So hopefully my drawing straight line tool works. I had trouble with this before. We'll see how we go. For the following graphs, you're going to use the by eye method to draw a line of best fit. Now, my line of best fit might be slightly different to your one. Okay, and that's completely fine as long as it fits these two guidelines. Okay, and this is where that fact where it says it's the least accurate method is because it's not perfect, because we're using a prediction made by a human and not real mathematics. Okay, so here, right there is my line of best fit that I feel fits this set of data points. Okay, you can also notice that there is 1 point above the actual line, really far above, which is right here, and 1 point below. Okay, if yours looks a little bit different, whoops, yours looks a little bit different, that's completely fine, but I'm following these two guidelines. Okay, I'm going to put in the line of best fit for the next three. Just give me 2 seconds and we'll have a little discussion. So here are my line of best fits for the next three. So all four all up, the first one being a negative slope and the next three being positive slopes. And again, it's just a prediction. Okay, it's nothing too fancy. I could probably, no, this one seems fine. There's 4 below and 4 above. If they're off by a little bit of an angle, a little bit, maybe 3 or 4 degrees on each side, that's completely fine. Okay, because again, we're just making predictions. We'll look into these 4 here, and then I'll break it up into the next video in part 2. Let's draw our line. Maybe we can have this one cut across like this, like so. And this one here, oh, I think that one's a bit off. We'll try that again. Maybe you'll start it at this point there. There we go. That seems pretty accurate. And this one is sloping downwards. So from left to right, it's going down. Maybe I can have it going like that. Yes. Now, draw your line of best fit. It's not rocket science, okay? It's not too tricky. But when we do our line of best fit for the next example that we'll see in part 2, we just got to be careful as to where this line goes in regards to these little grid spots, okay? So when you're using the line of best fit to model linear trend in data, we use the line of best fit, example, the red line in the example below, which will be in the next video, and the grid lines to determine 2 well-defined points. You then use the method explained in exercise 6E to fit the equation of the line. I'll leave it there. You're going to watch the next part in order to see this example.